The predictive skill of weather and climate models has improved dramatically over the past few decades, thanks to a huge increase in the spatial resolution of these models. The resolution of global weather models, for example, has increased from 500 kilometers to 10 kilometers over the past 4 decades. This resolution increase was facilitated by a huge increase in supercomputing capacity, a factor of around 1 million over the same time period. In the near future, further increases towards 1 kilometer resolution are expected to deliver significant improvements in model skill. Coupled ocean atmosphere simulations at 1 kilometer resolution would significantly improve the skill of weather forecasts by more accurately capturing coupled feedback processes between different components of the Earth system. Such high-resolution model simulations also have the potential to solve some of the long-standing systematic biases and uncertainties that have plagued climate projections for decades now. However, such models still face significant barriers to operational implementation due to their extreme computational intensity. Global kilometer-scale simulations on today's supercomputers are too slow for operational use by around 2 orders of magnitude in terms of simulated years per wall clock day. In order to close this gap and bring the models closer to operational reality, we must develop new ways to code and compute on supercomputers, always keeping in mind novel developments in hardware. For example, we must develop efficient time-stepping schemes to mitigate the substantial increase in computational cost, as not only spatial resolution but also temporal resolution is increased. Additionally, the hydrostatic assumption does break down eventually at very high resolution, and so non-hydrostatic dynamical cores have emerged to solve the fully compressible Euler equations. This 2-part mini-symposium will feature a number of talks addressing the aforementioned issues. We will have 8 speakers from institutions around the world representing the state-of-the-art in kilometer-scale weather and climate modeling today. For further details on the talks themselves, I encourage you to visit the video introduction of part 2 of our mini-symposium, which will be chaired by my colleague William Sawyer. So thank you very much for listening, and I do hope that you can join us.